5,000 people living, eating, working, and sleeping on a ship, not a cruise ship, a warship, one that doesn't pull into port for months at a time, that launches and recovers fighter jets around the clock, that operates in some of the most contested waters on Earth. And every single one of those 5,000 people produces trash every day. Without exception, think about what that actually means. Food waste, packaging, equipment wrappings, worn-out gear, and medical waste. The accumulated byproduct of 5,000 human beings living in an enclosed steel environment for 6, 7, 8 months at a stretch. On most ships, military or civilian, that trash gets sorted, compacted, stored, and eventually offloaded at a port. But a carrier can't always wait for a port. And storing months of compressed garbage on a warship isn't just unpleasant. It takes up space, creates health risks, and presents a logistical problem that compounds daily. The USS Gerald R. Ford solved this differently. Somewhere below the flight deck, past the hangar bay, deep in the engineering spaces most visitors never see, there's a machine running at over 9,000 degrees Fahrenheit, and it's eating the ship's garbage. The story of how a carrier handles its own trash turns out to be a window into something much bigger. How the Navy is rethinking what it means to keep a ship self-sufficient at sea. If you want more of this, like this video and subscribe to the channel. It costs you nothing, but it keeps content like this coming. Every conversation about aircraft carriers focuses on the obvious: the jets, the nuclear reactors, the catapults, and the weapons. Nobody asks about the garbage. But garbage is one of the oldest, most persistent problems in naval operations. And on a carrier, it's a problem at a scale most people don't consider. A crew of 5,000 generates an enormous volume of solid waste every single day. And unlike a land-based military installation, a carrier has nowhere to put it that isn't also needed for something else. Storage space on a warship is allocated down to the inch. Every cubic foot of space that goes to compressed trash pucks is a cubic foot that can't carry spare parts, ammunition, food, or fuel. On older carriers, the solution was incineration. Older-style marine incinerators that burned waste at relatively moderate temperatures, leaving behind ash and slag that still had to be stored and eventually offloaded. It worked, but it was inefficient. The residue still needed managing. And as carriers began deploying longer and operating further from port, the problem wasn't going away. It was growing. The Ford-class carrier was designed from the beginning to do something different, and the system they chose wasn't adapted from existing Navy technology. It came from an entirely different world. The word sounds like science fiction, but the technology is real, it's industrial, and it's been operating successfully aboard the Ford for years. The system is called the Plasma Arc Waste Destruction System. It was developed by a Canadian engineering company called Pyrogenesis, adapted specifically for shipboard use, and installed in the Ford during construction. The Navy wasn't taking a gamble on an untested idea. They were scaling down a process that had already been used in commercial and industrial applications, and fitting it to the specific constraints of a warship. Here's how it works. Waste is collected and sorted. Not everything goes in. Metals and certain materials are separated out first. What remains is fed into the system in a controlled stream. At the heart of the machine is a plasma torch. This is not a flame in the traditional sense. A plasma torch passes an electrical current through a gas, ionizing it and creating a superheated plasma, a state of matter beyond gas, where temperatures reach levels no conventional combustion process can achieve. Inside the PODS reactor, that plasma reaches over 9,000 degrees Fahrenheit. At that temperature, organic material doesn't burn. It disintegrates. The molecular bonds holding together food scraps, packaging, paper, and other combustible waste break apart completely, converting the material into a synthesis gas, a mixture of hydrogen and carbon monoxide, and a small amount of inorganic residue. The gas that comes out of the process is mostly harmless and is combusted within the system itself. What's left over is ash, not the bulky, contaminated ash from a conventional incinerator. A small, dense, chemically stable residue that meets environmental discharge standards for the open ocean. On a normal operating day, the Ford's pod system processes somewhere between 2,500 and 3,000 pounds of trash, and it reduces that volume, 100 pounds of input, to roughly 1 pound of output. And behind all of it, the engineers who built this system figured out how to eliminate thousands of pounds of waste at sea without dumping it in the ocean. If that deserves respect, comment proud below. The numbers are striking on their own, but the real significance of this system isn't the temperature or the weight reduction, impressive as they are. It's what the system eliminates. On every other carrier in the US fleet, solid waste management requires storage. It requires handling. It requires offloading at a port, which means scheduling port visits, coordinating with facilities, and accepting a logistical dependency that constrains how and where the ship can operate. The Ford doesn't have that constraint, not for solid combustible waste. A Nimitz-class carrier operating a long deployment has to factor waste management into its port visit schedule. Waste builds up. It has to go somewhere. A Ford-class carrier with PAWDS running continuously can manage its solid waste entirely at sea. The operational picture changes. Fewer logistical dependencies. More flexibility in how long the ship can stay on station without support. For a warship designed to operate in contested environments where port access might be restricted, delayed, or unavailable, that flexibility isn't a minor administrative convenience. It's a tactical advantage. A question that's worth asking. If PWDS handles solid combustible waste, what about everything else? A carrier at sea generates more than just burnable trash, sewage, oily water from the engineering spaces, medical waste, metal scrap, hazardous materials. Each of these has its own system. Sewage on the Ford runs through a vacuum-based collection system, quieter and more efficient than the gravity-driven systems on older ships, which had their own history of reliability problems. Oily water is processed through marine pollution control equipment before any discharge. The PAWDS system doesn't solve every problem, but it handles a category of waste, ordinary solid combustible material, that on every other carrier still requires manual labor, storage space, and portside coordination. The Ford reduced its crew requirements compared to the Nimitz class by design. Automation, improved systems, and better engineering throughout the ship. PAWDS is one piece of that. A small one, maybe, but it's a piece that runs continuously, below decks, quietly eliminating a problem that previous generations of sailors had to manage manually, day after day, deployment after deployment. There's a reason the Navy put this technology on their most expensive, most advanced carrier, and it's worth saying directly. The future of naval operations doesn't look like pulling into port every few weeks. It looks like extended deployments, more time in contested waters, less reliance on logistics chains that can be disrupted, targeted, or denied. A carrier that can manage more of its own needs at sea, power, water, waste, and food, is a carrier that's harder to interdict, harder to pressure, harder to predict. The PAWDS system is a very small piece of that larger picture, but it's the kind of engineering decision that reveals something about how the Navy thinks. Every pound of trash that gets converted to ash on board is one less logistical dependency, one less port visit that has to be scheduled, protected, and coordinated, one less vulnerability in the supply chain of a ship that's designed to project power far from home. That's the logic behind putting a plasma torch on a warship. The next time you see footage of an aircraft carrier at sea, the flight deck, the jets, the strike group arrayed around it. Remember what's happening below the waterline. 5,000 people producing thousands of pounds of waste every day, and a machine the size of a small room handling all of it at temperatures that approach the surface of the sun. It doesn't get coverage, it doesn't make headlines, but it's part of what allows that ship to stay out there month after month without coming home. If this kind of detail, the engineering hiding inside the world's most capable warships, is what brought you here, like this video and subscribe, because there's a lot more of this, and most of it is hiding in plain sight.